Good morning everyone. My today topic is buck converter. In this lecture, we will study the working of circuit, output voltage waveform, current waveform, and the output equation. This circuit we will study buck converter in two mode. Mode 1 is when CH is on, and mode 2 is when CH is off. This is mode 1 and this is mode 2. So let's see what happened when CH is on. This is the CH. This is our circuit diagram. This is diode. This is Vs, source voltage, inductor, capacitor, and the load. So when CH is on, so this connection is closed. This connection is closed. Current will flow from here to load and also through the capacitor. Current will flow through capacitor as well as from load. Okay. Now, what happens when CH is off? When CH is off, this is disconnected. This one is disconnected. Source voltage is disconnected from the circuit. What happened? Inductor store its energy during CH on. It will deliver its energy during CH off. Okay. This is same as type A chopper. This is type A chopper is also buck converter. In this buck converter, you can say that this is the type A chopper or buck converter with a capacitor. So let's see how these waveforms are drawn from the circuit. When CH is on, this is I naught, this is IC, and this is I. When CH is on, I naught will increase, IC also increase, I naught will increase during CH on. Okay. Now when CH is off, this inductor stored energy in the form of this polarity. It will deliver its energy in the form of this polarity. So the current through the circuit I naught will reduce. Current in the circuit I naught will reduce. So during CH on, I naught increase, and off, I naught will decrease. This is the voltage across the inductor. When CH is on, then voltage across the inductor is same as Vs. Polarity across the inductor and voltage across the inductor is same as Vs, positive, like this. When CH is closed, what happens? Voltage inductor changes its polarity like this. So voltage across the inductor is negative. So current is when current is increasing, at that time voltage is positive. When current is decreasing, that time voltage across the inductor is negative. You can say that during the CH is on, inductor stored its energy, and during the CH is off, inductor deliver its energy in the circuit. This is the waveform for IC, and this is the waveform for output voltage. Now let's see how our IC we will draw. When CH is on, listen carefully. When CH is on, this capacitor is charging, inductor is also charging, and current flowing IC and I naught through IC through capacitor and I naught through the load. Inductor and capacitor both are charged. When CH is off, inductor and capacitor both delivering energy to the I naught or load. This is IC. Both inductor, you can also say that at the time of starting, when CH is off, inductor is charging both IC and also deliver energy to the load. When inductor discharge, current flow through the load only due to capacitor. So when now at this time, suppose inductor discharge and capacitor deliver its energy to the load. So current will decrease through the capacitor, and you can say that a capacitor is used across the load to maintain the voltage. Let's see how it is starting from the negative. When only capacitor deliver its energy to the load, or current flowing through the capacitor is like at this time. When only capacitor delivering its energy, current IC will be like this. Okay, now again we switch on CH. So what happened? Assume that for capacitor, we assuming that the voltage across the capacitor is like this, polarity is like this, and the current through the capacitor is like this. So when CH is on, current due to through CH and inductor or Vs will flow through capacitor like this. Polarity is this IC. So this IC compared to this IC negative. So it start with a negative, and this IC will compensate this IC 0, and again IC will rise like this. Okay. When switch is off, this inductor deliver energy to this and this and this. After that it neutralize, and after that IC start to deliver its energy, or VC start to deliver its energy to the load. Okay, let's see V naught equal to the VC. There is a voltage across load is equal to the voltage across the capacitor. Assume that at the time of starting CH is on. When this inductor is charging, this inductor offer a large impedance. So due to large impedance, maximum voltage drop appear across the inductor, and less voltage drop appear across the capacitor or the load. So at the time when it start charging, the voltage is less. Voltage across inductor is more, and across this is less. This is, you can say that like this. Okay, when inductor is charged, so then impedance across the inductor is reduced. So voltage drop across the capacitor is increase like this. Okay, when it charged in this condition, fully charged in this condition, and after that it discharge, in again charge and discharge. So this is the waveform of the capacitor. You can also say that the current in the capacitor will lead the capacitor voltage by the somehow approx 90-degree angle. So this is the voltage waveform of buck converter. Now let's see the output voltage equation. How we will draw output voltage, how we will write our output voltage equation. This is voltage second balance equation. This is VL, voltage across inductor during on, and voltage across inductor during off. So you can say that stored energy in the inductor plus delivered energy in the inductor is equal to 0 for ideal inductor. Okay, for ideal inductor, stored energy in the inductor plus delivered energy by the inductor equal to 0. So see, when CH is on, what will be the VL equation? When CH is on, VL equal to Vs minus V naught. You can write the KVL equation. So KVL equation will be like this: Vs equal to VL plus V naught. So VL equal to Vs minus V naught. Okay. When CH is off, VL equal to minus V naught. Okay. VL equal to minus V naught when CH is off. So VL into T on plus VL into T on. VL equal to Vs minus V naught, this is T on, and VL during T off is minus V naught, this is minus V naught into T off. You can write T on equal to alpha into T from here. Suppose alpha equal to T on divided by T. We derive it in the type A chopper. You can see that lecture how it is derived. So T on, from this you can write T on equal to alpha into T. So T on equal to alpha into T. T of alpha equal to T on divided by T plus T off plus T off. Sorry, minus T off. This is minus T off. So you can write that alpha equal to T minus T off divided by T. So from here you can write T off equal to 1 minus alpha into T. This is it. When you solve this equation, you can find that V naught equal to alpha into Vs. So this is buck converter. In next lecture we will study boost converter.